Okay, so for this problem it says convert 300 liters of O2 to grams of O2. Okay, so it stays the same compound, so there's no mole-to-mole ratio that we'll need. But notice, it starts in liters, so what that means is we're going to have to use molar volume. Since it has liters, we're solving for liters, molar volume is what we have to use. So I'm going to write up molar volume over here. It's going to be 22.4 liters at STP. So there's 22.4 liters at STP of 1 mole of any gas, which we're going to use the gas oxygen since that's the one in the problem. So 1 mole of O2, 22.4 liters, sorry, this should say of oxygen, so O2 at STP. So this is one of the conversion factors. Okay. Number 2 that we should notice is that it says grams. Grams is a mass, so if it ever says anything about mass, we have to find molar mass. So that means we're going to have to find molar mass of oxygen. Also, I could have, if I would have just said convert 300 liters and said the word oxygen, remember it's diatomic, so that's one thing we could have added was Hofbrinkel, was you would have been expected to know that it was not 1 oxygen but 2 oxygens. But I did not do that. So the molar mass of oxygen, we're going to have 31.998 grams of O2 for every 1 mole of O2. So we have mass, volume, and we stay the same substance. So it looks like that's all we're going to need. But we'll see. So 300 liters of O2. So I'm starting with my underline, my givens, and I'm going to solve until I'm going to work the problem until I get to my circled, which is my unknown. So 300 liters of O2 is what we're starting with. We want to get rid of liters of O2. So what we're going to do is we're going to go over to our 2 options right now. We're going to look for the one that has liters in it. So if you look at the bottom one, it has grams and moles. Nothing about liters, can't use it. Top one says 22.4 liters of O2. Absolutely we can use it. So I'm going to use 22.4 liters of O2. It says at STP. That's fine. We'll end up using that later. So we're converting 300 liters. And so since we put liters on bottom, we now need to put the 1 moles of O2 on top. So we need to flip that. Okay, so now we got rid of liters of O2, and we're now at moles of O2. Notice our unknown is mass, so we need to get rid of our moles. We got rid of this one, so I'm going to cross it out. So I'm going to go to our only other option, which has moles in it of O2. So perfect. Moles on top, moles goes on bottom, so I'm going to put 1 mole of O2 on bottom. And I'm going to put mass on top. Moles of O2 cancels out. Now I'm going to multiply all my numerators, divide by all my denominators. You get 428.5 grams of O2.